Hi, Dr. Versalotti here, and in this video we're going to learn how to analyze phonological relationships between sounds in a particular language. In other words, we're going to learn how to solve phonology problems. We are using the How to Solve Phonology Problems 1 worksheet. When we solve phonology problems, we need language data. Linguists collect this information by working with users of a language, but here we're going to use pre-collected data sets, often simplified data sets. Note that the data is here at the bottom of the worksheet, and the data includes the word and IPA, and because we care about how the word is pronounced, and the word's meaning translated into English. We need both the phonological form and its meaning to consider the various phonological relationships. Now, the questions we're going to consider in this video are listed above the data here. The first question that we're going to consider is we're going to consider S and Z. We're going to think about where they show up in the data, what their phonological relationship is, and we're going to use the information to make a claim, and we're going to give the appropriate linguistic evidence to support our claim. Okay, let's get started. Step 1 is review the data. The first thing we want to do, always, is just check the data. Are there minimal pairs in the sounds of interest, which are S and Z in this question? Remember that minimal pairs are two words that differ by only one sound, and that sound difference results in a different meaning or a different word. Do we see any minimal pairs in this data? Pause the video to check. Looking through the data, we see the word zo, meaning elephant, and so, meaning conform. We see that if we swap one sound out for the other, the meaning of the word changes. With that information, we know that in this language, S and Z are allophones of different phonemes. Because we can't swap one out for the other, if we do, it's going to be a different word. So we can also see that both sounds can be at the beginning of the word and be followed by the O vowel, so it means that they have overlapping distribution. That's just the linguistic way of saying that they show up in the same places. So when we give the linguistic evidence to support our claim that they are allophones of different phonemes, we have to list the minimal pairs of zo, meaning elephant, and so, meaning conform. We can't just say that there are minimal pairs, we have to actually give them both in the IPA, the pronunciation, and in the meaning. Okay, now our analysis is complete. We're ready to move on to our second question. We're going to compare the sound S with the sound sh. We're going to think about where those sounds are distributed in the language. Where do they show up? What is their phonological relationship? And what evidence do we have to give to support our claim? Okay, we're going to start where we always start, reviewing the data. Are there minimal pairs in the data for these two sounds? Pause the recording and check. No, there are no minimal pairs in these two sounds, for these two sounds. What about free variation pairs? Free variation pairs are two words that differ by just one sound, but the meaning of the word does not change. Speakers of that language can choose which sound to produce, and the meaning is the same. That would be like pass the butter or pass the butter. Either way, you know what I mean. Because that middle consonant, those two middle consonants can freely vary. The meaning stays the same. So pause the video and check for any free variation pairs. Okay, there are no free variation pairs in this data for the sounds s and sh, but if they did, they would be allophones of the same phoneme, and we would give the free variation pairs just like we did for the minimal pairs, but the meanings would be the same. Okay, since there are no minimal pairs for the sounds s and sh, and there are no free variation pairs, we have to then consider if the sounds are in complementary distribution, and the allophones are therefore allophones of the same phoneme. In order to do that, we have to move on to step 2, make an environment list. Okay, I started an environment list up here on a Word document, and you can just do this on a scrap piece of paper that you have handy or in the bottom part of your handout. In order to start the environment list for each sound of interest, I just wrote the sound of interest, the s on one side and the sh on the other. Now we can just look at the data to observe where each of these sounds shows up in this language. For instance, we see here in the first word that s is word initial, the beginning of the word, and it's followed by o in that word for hand. We see that s can also be at the beginning of the word followed by open o in the word for sack. So we can just list those underneath our s list. Next, we look at the third word, which is the word for 13, and we see our sh sound. Here we see that sh can be word initial and followed by e. Oh, and there's another s sound, and we can see that s can follow p and a can follow it. So we're going to add those to our lists by just looking at where the sounds show up. Here I've highlighted where the s shows up and where the sh shows up in different colors. And that's just a visual way to help me make sure that I find them all. And we can continue that process for the whole data set, observing where the sound shows up and writing it on our list. Pause the video to make your environment list. Here's the environment list that I came up with. Notice that I stopped writing the s and sh, and I just used an underscore to indicate where the sound of interest is in the word. But it's the same thing. This just means that the s sound shows up word initial and can be followed by the k sound. Okay, now that we've made our chart, we can move on to step B, which is to look at the preceding environments in each list. So this list here and this list here. Do we see any of the same sounds on both lists? Yes, both s and sh can be word initial. Remember, the hashtag means word initial. And look, also, this vowel can be before our sounds of interest. Since there are these commonalities, we can we kind of think that maybe the preceding environment isn't what we're most interested in. Let's remember that we're making these lists to see if we can observe why the s sound and the sh sound might alternate by where they are in the word. So if the preceding environment has some of the same sounds, then it probably isn't what's triggering the change between a s and a sh. Now, what about the environment following the sounds of interests, the ones after the sound of interest? Are these the same? No, we see a pattern, right? We can see on our list that the sh sound appears only before the E sound in this language. So now that we wrote our environment lists and looked at the environments, we're ready to describe the pattern. Okay, so how do we do that? We're going to move on to step 3. We know that the sound sh shows up in the environment right before E. And that looks just like our environment list, right? We had the underscore representing the sound of interest, and then the E sound. We also know that S shows up everywhere else in the language. So now that we've described where each sound shows up, we have to decide which sound to use as the phoneme. Remember, phonemes are theoretical. By convention, we put the allophone which is found elsewhere as the label for the phoneme. And this generally aligns with what speakers of the language considers to be the sound in the language. Even though we know that these sounds and sh are pronounced slightly differently, for speakers of this language, they generally will hear them as the same sound. Okay, so our conclusion is that s and sh are allophones of the same phoneme, and the evidence that we can give is to describe the pattern. We're going to do that in this linguistic notation, and we need 2 lines because this problem asked about 2 sounds in the language. So our evidence to describe this complementary distribution is that s shows up as sh before E, and s is pronounced s everywhere else. We've solved both of these phonological problems. In one case, we had minimal pairs showing that the sounds are allophones of different phonemes because there are different meanings. And in the second case, we've concluded they are allophones of the same phoneme because there are no minimal pairs and they show up in complementary distribution, and we can describe where each one shows up. It's predictable, and we have that description in linguistic evidence.